Hello everyone, my name is Andrei. In this video, I want to talk about the FX map node. We're going to create a few basic to intermediate to advanced examples. I already have a few examples here. These are basics, and then we're going to create from scratch a few intermediate, and then at the very end, something a bit more advanced. Before jumping in, I want to thank Marco Vitale and Nicola Wirman for showing me a few examples of how the FX map node works. I also recommend having a look at some of the already existing nodes in Substance Designer that use the FX map node in order to understand possible use cases for it. In a nutshell, the FX map node, it's taking patterns and scattering them into the 2D space. It also allows a few actions where you get to choose or control the positions of the patterns, the scale of the patterns, the rotation, and the color or luminosity of those patterns. Also, you have the possibility to input multiple patterns and use gradients or masks to control what patterns are scattered in what area. Okay, so let me briefly show you the examples that I created here. In this first example, we have a grid of squares, and then we use this Berlin noise map to control the scale of these patterns. If you're familiar with the tile sampler node, you guessed by this time that you can input this Berlin noise map into the pattern size input of the tile sampler, and you're going to get this effect. But here you have the chance to actually do this effect on your own. So for example, going in here and changing the disorder of this pattern, you can see that affects the size of the pattern here in the FX map node. And as you can see, for example, in this area where the patterns are small, this is driven by darker values in the FX map, in the Berlin noise texture. So for example, this area here where the patterns are small corresponds to this darker region here. In this example, we're using a normal map to move the patterns around, so this actually have this effect. So you can go into the normal map node and use the intensity parameter to just control how much the patterns are pushed in the FX map by this vector field here. In the following example, we're using a grayscale checker map to affect the color of the patterns. So you can see all the patterns inherit the luminosity or the color from this histogram range. In this example, we're inputting this gradient to drive the rotation of the pattern. And here we have a combination of all those individual effects. So we're moving things around, we're also coloring them, and we're also using this this map for the rotation. In this example, we're going to switch between two patterns. So we have two input images this time, a square, a circle and a square. And then we are going to use this map to switch between those patterns in this 2D space. So we can input any kind of image here, and this image is going to control which pattern it's displayed. So as you can see here, whenever we have brighter values, we display the circle, and whenever we have darker values, we display the square. Here we're doing a similar technique, but with a few more controls. So for example, you can see that we are doing also two patterns, a square and a circle, but we added this new functionality where we can only affect and move the patterns. We can only move the squares but leave the circles intact. So if I play with this parameter, you would see that only the squares are affected and the circles are just left untouched. And at the very end, I have a few other examples that I will cover when I reach those nodes. For example, here you can create these kinds of alternating patterns of disks and squares. And also lastly, we use this Berlin noise map to kind of take this image and subdivide this grid into smaller and smaller rectangles based on the brightness coming from this texture. So you can see that this darker patch here corresponds to a more dense grid, while lighter regions have a larger grid. So I think this effect is interesting. So maybe we can play with this disorder so you can see how things are changing. All right, so let's start with the first example, and just for the sake of making sure the learning process is complete, I'm going to start from scratch. So I'll make a new Perlin noise. I will reduce the scale, something like that, and then just create an FX map node. In this case, we're going to use the grayscale version, so check this option. And also we're going to set this parameter roughness, we're going to set it to 0. Okay, and then we're going to plug this map here into image input 0, and then with the FX map selected node, you can either go somewhere. Where is the edit? Well, I get so used to selecting the node and hitting Ctrl+E, which is entering the edit mode. So I'm just going to do this action in order to get inside the FX map node. Select the FX map node and hit Ctrl+E. Okay, so this is the quadrant node that we are presented with. First things, I will go here and choose, instead of no pattern, I will choose square. So now we have a square filling the entire 2D space, and I will go here where it says pattern size, and I will just decrease the square a bit. So maybe 0.9 and 0.9. Okay, So far so good, right? And then kind of how these things work from now on is just you can start and add quadrant nodes like so. So plug this square into this new quadrant node, and now I select this one and set this one as a root, and you can see that it took our square and um, created a grid of 4 squares, and I can continue doing the same, not this of course. I just want to click somewhere here into the canvas and then hit the quadrant button to get a new one, create those connections as well. Now set this one as a root, so you can see we have a grid of 4 by 4, and we can continue to do so. I'll create another one and just want to show you a faster way to connect these wires. So if I hit Ctrl plus Shift and then drag from this to here, then all of my connections are created for me. Set this one as a root, so again subdivide, and I'll do one more, so maybe like so. Ctrl plus Shift to make all the connections in one go, and set as root. Good. So now I want to use this map here to control the size of those patterns. And this is a very simple thing to do. We go at this node, which is at the bottom of our tree of nodes, and here into where it says pattern size, we're going to dive inside. Everything is going to turn white. This means our pattern size got restored to a default value of 1. If you remember, we set it previously to 0.9 and 0.9, and now it's back to 1. Here inside this channel, we're going to use this input map, and we're going to use it to drive the pattern size. So those values range from 0 to 1, which is something that we want, of course. And in order to get that image and use it here, we need to call in the position variable, so it's a float 2. And remember, this we're going to use the $position or $pos variable a lot. I think it's the most used. It's fair to say it's the most used variable in Substance Designer. So if you don't know exactly why we're using it, don't worry. For now, we're going to cover or talk about it more. But you're also going to see it so often that you're just going to know by default that pretty much all the time this is what we're going to use. So the dollar position, it's actually a vector field which holds for each pixel its position, and this is looking like a map. I can actually show you how it looks going into a pixel processor and then get the position. And in order to see how it looks, we need to output either a float or a float 4. This is a float 2. So in order to be able to output this one, I need to make a vector float 4, something like this. And this I can't output. You can see like set as output node, it's deactivated, but this one is a float 4, and it is what Substance Designer expects. So if I right click this one and set it as the output node, it's going to show me this. Now it is transparent because I don't have an alpha. I can either turn this on or off, but maybe for the sake of correctness, I'll do another float 2 and set the alpha to 1. Okay, so this is how the position vector field looks like. Okay, now um, set this aside for a bit. I'll go back into the FX map. I'm going to hit Ctrl plus E to go inside. We're working with this quadrant node. So into the pattern size, we just got the position variable, which if you remember, it's just that gradient. And we're going to sample with these coordinates. We're going to sample from our input image. So sample grayscale and the input image is 0, that's fine. And this is basically just bringing the information from this outside texture. It's bringing the information inside this channel, and also it's going to be used to color, not to color, but to affect the size of those patterns. So great. Now we should be able to use this information and set it as an output to control the size of our patterns. But if I want to do so, again, I'm not allowed. So you can see set as output node is not available. And this is again because the output variable type is a float 2. Currently this is a float 1. It's indicated by this green dot here, and we just need to make a vector out of it. So vector float 2, right? So you can see it's taking as an input this and this, and now I can set this one as an output. Well, great. Now it seems to be that our pattern scale is controlled by this map, which is absolutely amazing, right? Okay, this is the first example. In the second example, we're going to use a map, a grayscale map, turn it into a vector field, and then use this vector field to push the patterns around in our 2D space. Okay, so maybe it's going to be a bit redundant, but for the sake of repeating things, I will recreate things from scratch. So what I usually do is that I can take this setup that I already have, duplicate it, and then replace this part and change a few things inside. And that's a bit faster to do, but I want you guys to repeat the steps a few more times from scratch, and I think you're going to understand a bit more and also get a bit more comfortable if you repeat the process. Okay, so then let me try and replicate this example here, but we're going to use a different grayscale input. So just want to say that my absolute favorite noise and node in Substance Designer is the Perley noise, but a similar one to it, it's the Gaussian noise. So Gaussian noise, I think this one. I will decrease the scale also, something like this. Then I will put a normal map and maybe increase the strength of the normal to 3, maybe 16 for now, just for us to be able to see some variation here. Maybe 128. That's definitely too much, so we're going to decrease this value, but just for visibility, something like this. Okay, so a new FX map node. Make it grayscale. Go to roughness and make it 0. Plug this normal map into image input 0, right? Then into the quadrant node, I will use this time a disk as a pattern. Maybe the pattern size, I will decrease it for a bit, 0.9 and 0.9. So not that, 0.9. Great. Okay, so what I want to do next is, instead of controlling the size with the map, I want to control the pattern offset. So go inside here, and I want to bring in the information from this vector field. So how to do that? Well, remember we use the position variable, and now we need to sample, and we're going to sample a color because this information is color, and here we sample a grayscale because this was a grayscale image, right? So sample, and then I only need to work with the X and Y components. So this is a float 4, but I only need to access the X and Y components of this. So swizzle float 2, so I'm going to get the X and Y. At this point I need to show you something. So maybe let's say that I do this and output this, and you can see like things happened. Somehow it seems like I got some movement, and let me just bring this down to maybe a value of 3. Okay, and then what else do I need to do? Well, I need to put a few more of those quadrant nodes that are going to duplicate, and it's going to create my grid. So I can also take those things and duplicate them like so. Okay, great. Maybe do another one. Okay, so let me show you something. Maybe put this to 8, and I hope it's going to be visible. This is a bit interesting. Let me just test this one. Okay, this is a bit interesting. So let me make sure that it seems that we're not getting the effect that we wanted. So we currently have a disk here in the middle, but we seem to be somehow pushing things from the corner, not from the middle. So if you remember, our example here was everything from the center, right? So we should have the same effect here, but instead of having it from the center, we have it from the corners, and not sure why. So first of all, let me do this. In here, I want to take this vector field and make it to range from 0 to 1. This is the current range. I want to make it to transform it in a new range, which is from -1 to 1. And this is important because all the vector fields in Substance Designer are bound between 0 and 1, but inside all the other nodes, they are kind of unpacked and reshaped into this new range, which is from -1 to 1. So we need to do this for ourselves right now. So in order to do this, I can multiply this by 2. So scalar multiplication, this is a vector, I want to multiply it by a number. I need to use the scalar multiplication node, scalar multiplication, float 2. So remember, this was from 0 to 1, and now if I multiply it by 2, it's going to be from 0 to 2. Okay, great. So everything started to move correctly to the center, but then now we need to actually make it from -1 to 1. So this is from 0 to 2, and in order to do this new range adjustment, we need to subtract a float 2, which is going to be 1 and 1. So 0 to 2, if we subtract 1 and 1 from it, is going to be from -1 to 1. Okay, Good. So now it seems that we have it working correctly, which is already interesting. So now I want to plug back our original texture. Okay, delete this one and maybe play with this one a bit more, maybe 5. Okay, so I want to also do another thing, which is, as you can see, when we pushed those circles together, some of them start to overlap. And we're using this map here to control this effect. And it's interesting because we already have some information that we can use to drive the scale here. So I want you to notice that in this area, for example, where the circles are very close together, actually corresponds with this dark region in our Gaussian noise. So maybe we can just take this Gaussian noise and plug this into the FX map node to control the size of the disks. And this will allow us to avoid as much as possible the overlapping of those disks. So let us do that. We're going to plug the Gaussian noise into this image input 1, go inside, and also at the very bottom of our tree node, click this one, go into pattern offset, not here, sorry, go into pattern size. Our disks increased a bit to the default value of 1, but we're going to get the position variable, and we also going to sample this time a grayscale image because our information is grayscale, but also make sure that the input image is coming from the channel input image 1. Set this one as an output. Well, I want to do so, but I can't. And why isn't it possible? Well, if you remember, all the time make sure that you check the expected type of variable that you need to output. So this is a float and we need to make a vector float 2 out of it. So vector float 2 and make this. And what really means is that we're plugging in those same values here, but this is kind of like the width and the height, or maybe the other way around. Maybe this is the height and this is the width. No, actually this is the width and this is the height of the pattern. And if we are plugging the same information in both, we're just keeping the ratio the same for both, so we don't stretch it in either direction. Okay, so set this one as an output, and then you can see we have the patterns in the darker regions smaller. Maybe I wonder if we can do something about it. Maybe we can, if you wonder how could we increase the, how can we increase the size of those patterns because they got too small. Or maybe one way to do it is just put like an auto levels. So before auto levels, after auto levels. So this seemed to help. And also if you want even more control, you can just go inside here. And in pattern size, you can multiply this value by a lower or larger than 1 number. So maybe scalar multiplication, again, this is a vector we want to multiply it by a number. So 1. Now, of course, you know that if you multiply anything by 1, nothing changes. But then if this value goes lower, then everything decreases in size, or if we increase this value, then we increase the size of the patterns. Okay, great. So I will leave this to 1 and move to the next example. So let me try and remember what the example was. Well, we're going to make a grid of patterns, and then we're going to color or change the luminosity of those patterns based on a map. Okay, so I'll use again my favorite noise, which is the pearly noise. Something like this. Maybe 4. I'll also use a quantized grayscale. If I could type correctly, it would be good. Something like this. Yeah, I think this is good. I'll create another FX map nodes from scratch. Make it grayscale. Remember to set the roughness to 0. Plug the pattern into image input 0. Plug the noise into image input 0. Take this one. Use a square pattern. Change the size a bit. Okay. Go into the luminosity channel. So by this time we used 2 channels. We used the pattern size and the pattern offset to control the size and the offset by input images. Now we're going to use the luminosity channel to affect the luminosity of the pattern. So go inside here, get flow to, you guessed it by now, we're going to the $position variable, and we're going to sample from it, which is essentially bringing the image inside. So our luminosity has decreased, which is an indicator that things are working, and now we just need to subdivide. So not this. When this happens, it means that you have this node selected, and if you press this, well, it was, let me try it again. So with this selected and with this, it's going to connect like so. This is not what we want, so I'll delete this and just click anywhere else in this space, and then just one click here and Control plus Shift to connect everything in one go, and then I can duplicate this, so Control plus D to duplicate, and then Control plus Shift, and then duplicate again, and then Control plus Shift, and maybe one more, and Control plus Shift. Great. So now we have this basic tree graph. Set this one as a root. Okay, so you can see we're using this map to color our grid of square patterns. Next, we're going to move quickly with this one. We're using a gradient to control the rotation of this pattern, so let me use again my favorite noise. I will just change the random seed to get like a slight variation. Use an FX map, make it grayscale, roughness to 0, and then plug this thing here, go inside, maybe make a square, again change the size, maybe 0.8, 0.8. Go inside pattern rotation, so we use those channels, luminosity, offset size, and now we're going to use pattern rotation. Okay, so let me do it normally. Get float 2, you guessed it, it's the position, sample, set this as an output, it rotated a bit. Now we want to do our subdivisions. And maybe this time we're going to be 6. So by this time we only used 5 repetitions. Now I added one more at the end. Doesn't really matter. Set this one as a root. And you can see maybe it's a bit hard to read. It's because maybe there are too many patterns. Let me try something like this. This is, I mean, you can see the rotation, but you kind of can't really see the organic pattern under the hood. So maybe this one seems to be a bit better, and maybe for the sake of visibility I will just go here and into the luminosity also bring in the same image so we can see how the color of the, I mean not the color, the luminosity or the brightness of the Perlin noise corresponds to rotation. Yeah, so now you can see them. And also I want to say, well, maybe you're wondering why do we have those bright corners here? Well, this is because the blending mode that happens to our patterns. So I think here we have it to add and sub, and because those patterns are overlapping, when in these areas the brightness of those two squares together gets added up. Maybe if I change it, I'm not sure, but I hope it's going to make this disappear and just output the brightest of those squares. So this is the maximum, and yeah, indeed, it got rid of those things for us. Okay, so now it seems like we're able to read the pattern and also see how the brightness of the image affects the rotation of the pattern. Great, we have this example out of the way. Now we can put all things together, so we're going to use everything combined. So maybe use yeah, of course, Perlin noise. I was thinking about another favorite noise, but I realized that I don't have any other favorite noise, so Perlin noise it is. Just change the random seed somehow. Maybe okay, maybe 5 for scale. Put a normal map. Make the normal map strength to 3, how we used before. Make an FX map from scratch. Grayscale, plug the normal map inside. I'll just move the normal map above a bit because I also want to use this as a scale. So this is pushing the patterns around. This is going to be our scale. So go inside, use a disk, set the blending mode to max, maybe, then go into the pattern offset, get the position, sample the color. This is the vector field that tells us how to move our patterns. So image input 0, it's our normal map. Okay, go inside, we have it, but you remember that this is from 0 in the range 0 to 1, and we want to make it always in the range from -1 to 1. So we need to multiply this by 2, and in order to multiply by 2, remember this is a vector, and we need to do a scalar multiplication, which allows us to multiply a vector by a number. So scalar, well, scalar, yeah, it's scalar, not so I was typing SQ instead of SC. So multiply it by 2, and then we subtract 1 from it. So this is a float, this is a float too, which is compatible with this one. So I can plug this here and then set this as an output. You can see how things offsetted a bit. Now I need to do my subdivisions or duplication depending on how you want to think about it. Duplicate, duplicate, and one more, duplicate. Okay, move this out of the way so we can visually see that we have our controls here. Set this as a root. So now we have this like so. Now, why do we see all these patterns in a gray value? Well, it's because we have this roughness set to 1, and in all our previous examples so far, we moved we changed the roughness parameter to 0. Great. So we have it like so. Then I want to, as we did here, I want to use this map to change the scale of the patterns. So go here, we use the offset, now we use the pattern size, get float to position, then sample, but this is the image input one, and then make it into a vector float 2, because this is what Substance Designer wants from us in this channel, and then set this as an output. Well, great, we have it. Next, what do we want to do? We also want to do color. Maybe I'm going to take this one from here and just plug this thing in, go inside the FX map, go where we control things, into the luminosity channel, bringing the position, then sample the information that we want, which is in image input 2, and set this as an output. So things have changed in terms of luminosity. And lastly, we want to do rotation. Well, kind of you can't see the rotation here because I unfortunately used disks. So if I rotate disk, you're not going to be able to see the rotation itself, but then I can actually change it to square. So now all my squares are not rotated, but I can use another Berlin noise to randomly rotate everything. So go here into rotation, get the position, and then sample it with the map or information that we want, which is in this image input 3, and then use it. So now everything has randomly rotated. So in conclusion, this example here is a combination of all of the examples above. Next, we're going to use another parameter which allows us to, for example, input two patterns and then use a map to basically decide in which area one pattern will be shown and in the other area the other pattern will be shown. So I will take a gradient, maybe can be a vertical one, and I will just duplicate these two, make an FX map. Maybe I can do this. So first of all, plug in the patterns, so like this, and then plug in the map that we're going to use to define our areas, change it to grayscale, go inside. Instead of now, up to this point we used predefined patterns, but we can use actually input image, which allows us to use patterns from outside the FX map node itself. So I use this one, and then maybe here set it to max, and for now just duplicate things, so not like this but like this. I didn't know what I've done. I think I hold Ctrl plus D continuously, so that's really good. And another one like so. Then move this out of the way so we know that we're working with that. Now we had our subdivision. We go here into roughness, make things white again, and then we want to use this map to control which pattern shows where. So probably we're going to have it like this, maybe circles on top and then squares on the bottom. Okay, so in this quadrant node, we are going to use input image index. We're going to use this channel here and get float to position, and then we're going to sample, and then what we're sampling is image input 2, so this one. But I want you to know, like, okay, how to use this information. Currently what it's saying that expected output type is integer, and if I go back out of this and select this one, you can see that maybe I actually just reset the function for a bit, and you can see that image input actually says like, hey, image input 0, 1, this is the square, 2, this is the gradient itself. So 0 it's the circle, 1 it's the square, and then 2 is the gradient. So we want to select between the circle and the square based on our gradient. So how to do that? Well, we need to go inside and say like, hey, get our gradient from top to bottom, and then we're going to say like, hey, if, I mean not yet the if statement, but we're going to say like greater if the values in our image are greater than 0.5, right? Then we're going to say if, so if this condition is true, then an integer, 0 if you remember was the circle, and then 1 was the rectangle. So I guess what we're saying here is that if the values in this gradient that we're inputting are greater than 0.5, then display this index, and this index brings in the circles. Otherwise, display this index, which brings in the squares. So then if I hit this as an output, I should be seeing circles at the top and then squares at the bottom. Or you never know, vice versa, because I always get confused about this logic, but at least we should see squares and circles, half of the image. So, well, we got something interesting, which is this circle and square, but we have this disk in the middle, and I think it has to do with the fact that I'm sampling this image input 0, which totally makes sense because image input 0 is the disk, but what I really want to do is sample this image, which is image input 2. So back here, so that was a little mistake that I've made. Instead of sampling image input 0, I need to sample image input 2. Okay, so as I mentioned, I'm seeing circles at the top and then squares at the bottom. Great. Well, now you can think about like, hey, we're using just this gradient. It's not that interesting. I can do this with a normal mask and things like that, but maybe again use a Perlin noise. And decrease the scale and maybe change the random seed and decrease the scale a bit more, maybe 4, and throw in a auto levels after this. And now if we change this to this, we're going to see a more interesting result. Okay, perfect. I just want to say that up to this point you can do all of these effects into using the tile sampler node. That's totally fine. So up to this point everything was just like basic things, but maybe you didn't know how to do them and you wanted to do them from scratch, and I think it's always good to just know or understand how things work. But then we get into this example where we have this interesting effect here where we have circles and squares, but the circles are left alone and they're like just sitting in the middle, and then everything else changes. So for example, only the square changes their position, but not the disk themselves. So how can we do this? Well, I'm going to introduce the, up to this point we use the only the quadrant node, right? And next we're going to introduce this node, which is the switch node. So this is kind of like an if else statement, right? Okay, so I'm going to show you how to do this interesting effect. Well, first of all, do an fx map node, make it grayscale, go into roughness, make it 0, go inside, make disks like so, then duplicate, not this one, sorry, maybe not duplicate yet, make another one, and this time do squares. So if I output this one, I see a square. Let me decrease the size a bit, so 0.9 and 0.9. Okay, so I want before subdivision or before duplicating my patterns into a grid, I want to put this switch between them. So here circle, here square, and if I output this one, it's showing me the disk, and if I play with this button here, I switch between those two, right? Okay, so now I do the duplication, so not here but above it, so duplicate. Okay, so duplicate again and a few more times, right? And another one. Okay, so connect everything together like so. Good, so we have again grid of disks. If I change this, grid of squares, grid of disks. Good, now I want to use this map to first of all select between the two, like have the disks showing in one area and the squares showing in the other one. So maybe I'll use this disk here, go inside, and in order to make the switch I need to use this node here. So I can go into this selector expression and create a condition that will switch between the inputs based on this condition, if it's true or false. So get flow2 because I want to bring my image inside. Sample, if we remember, we're sampling image input 0, right? Here, go inside, and I will say if is greater than 0.5. Now, this is like not wrong or right to do. So I don't have any, you wonder why, like, hey, this image is like fully binary. It's full white here and full black here. Why do I bother to say like, hey, if my pixels are greater than 0.5, why didn't I say like, hey, uh, if my pixels are equal to 0 or 1, right? Because I have like pixel equal to 0 or 1 here, and I should base my condition on what I already have here. And that's totally right. But sometimes uh, there might be conditions in which knowing the exact value of the pixel might not work all the times, or you might have errors where the pixel actually seems to be 1 but it's actually not 1. It's like maybe 0.9999999. And I noticed that you kind of can get into trouble if you're not careful with equality. So for example, saying like, hey, if pixels are equal to 1, then this is like a super strict condition where it says like, hey, it really needs to be, the pixel needs to really be equal to 1. And this needs to be strict, and sometimes this strictness might be causing you problems. But here, as a safety measure, I would say like, hey, if the pixels are greater than 0.5, well, everything, I'm pretty sure that everything in this disk here is greater than 0.5, right? So I really don't care. Maybe I can put 0.55 and I'm still okay. So this is more like a safety measure for myself. Maybe there are better ways to approach it. I think the more you play with it, the more you'll figure out what and when to use it, and of course you'll have difficulties and problems when things are not going to work because some minor obscure reason that you missed. Okay, but I will set this one as an output, and this is a boolean, so our beautiful node here expects a true or false statement, and this variable here, or this node which has this white output, it's actually a boolean. You can also do this uh, boolean, so true or false. If I set this one as an output, and let me visualize the node itself, so it's outputting circles. If I switch this to true, it's outputting squares, circles, squares. Basically this, it's doing the same thing that we had here before when we had our buttons. Okay, but now I'm going to use this statement here. Okay, so now we got based on this map, we got squares in the middle and circles everywhere else. Now good. And let's say we want, based on this condition map here, we want to affect only one pattern and leave the other alone. So I'll duplicate this noise here. Okay, bring it inside, and I don't remember, I think this one was the circles and this one was the squares. This one, yeah, the squares, this one is the circles. Okay, so then in this node here, we can go here inside the pattern offset, right? And just bring in our vector field. So sample, color, it's image input 1, right? Now extract the X and Y components. Remember that because it's a normal map, we need to change the range from 0 to 1 to -1, 1. So scalar multiplication, float 2, and then we need to subtract float 2, 1, and 1. Okay, so I like to arrange them like so, and then output. Great, so you can see that we're only affecting those circles and not the rectangles, right? And then I can change this. Maybe instead of a disk, I can make it a square. And you can see how things are adapting. So I think this effect is a bit more interesting, and maybe it's not so, I mean, definitely it could do it by with the default nodes that we have in designer, but I think it's interesting to understand that you can do it by yourself from scratch. So let me also make the squares a bit less or a bit darker. Okay, perfect. Okay, so we made this example as well, and we have this and this. And I want to very briefly touch on this. Up to this point, uh, this is kind of a way to use the FX map node which works, and I think it's made a it's kind of very useful to create like grids and patterns and noises, but there's a different way to use the FX map node, and I think for somebody who comes from a programming background with loops and things like that, I think the next way to use the FX map node that I will show you, I think that it's going to be probably going to make a bit more sense or feel more familiar. But yeah, those two examples, I really didn't have the time to figure out or to play too much with it. I think it's still pretty powerful. Maybe I'll just play a bit more and try to figure out why and how to use this thing. So I will go inside this node and kind of start from the bottom and uh, try to explain what's going on. So you can build these graphs in an interesting way. I mean, let me just bring it or start to do it again from scratch. I think that should be a bit okay. So we're building from scratch a new FX map node in which we aim to do an example like this. So let me go inside, choose a disk pattern. Also, let me preview this one. Go here to roughness, set it to 0, right? Then I will duplicate this node here and make a square instead. Set this one as a root for a brief moment. Decrease the size. Okay. So what you can do actually, up to this point we used quadrant nodes and we connected them like so. And this is our disks, and I can even do another one like so, maybe like that. But then maybe you want to get creative, and instead of fully connecting a quadrant node to all the 4 inputs, you can maybe select or use this or use this pattern which currently has those 4 circles, and maybe you can input them only into the bottom part. So if we are to preview this, we can see that this is this part and this is this part, so maybe just disconnect this. Okay, so the last one is this quadrant here. The second one from the right is this part here, but you remember that here we had squares, so maybe we can do this one, and also you can take another one and just choose like maybe another pattern of paraboloid, something like this, right? So now you made this pattern that you can just take in and then plug it like so. So things like that. Okay, right? So you can get creative, and I think this is a really powerful way to work. Just haven't played with it much, right? Okay, so I encourage you to get creative and also use, I don't know, maybe use switch nodes here in between. So for example, we have this and this, and you can put this here and then maybe put like a condition inside this, and then when it changes between these patterns and stuff like this. So I think this is a really powerful and interesting workflow that I haven't tested so far yet. And lastly, I want to talk about this example. So you can use, for example, a map like this and then uh, change the disorder of the Perley noise, and it's going to give you like an interesting effect where the tessellation or the subdivision changes based on the luminosity here. And I just went inside and made a few patterns, so we're going to preview them. It's going to be this pattern and this pattern and this pattern, so we have a couple of subdivisions, and then we're just switching between this, this, and this based on these switches. And at the very end, I needed to add a couple of subdivisions like here, right? So inside of those switches, I just take the input image, which is that Perley noise gradient, and say like, hey, if the gradient is lower than 0.5, then do either one of those. And then next I say like, hey, if the gradient again is lower than, in this case, 0.25, then do either one of those connections. And then I just need to subdivide this, and now I'm getting this tessellation, right? So you can add another one if you want here, and you're going to get like even a subtle more grid like so. So I believe this needs further exploration, and I think it's going to give you like really cool and interesting patterns. Okay, good. So just wanted to say that this is one way of working with the FX map, in which you go inside the FX map and you chain a bunch of quadrant nodes, and then you maybe going to use the switch node to switch between different branches and things like that. And I think this is very powerful and creative, but at the same time it feels a bit, I don't know, maybe a bit unintuitive from a certain point of view. So that was like the first part, and in the second and third part we're going to change things, and we're going to use the FX map in a different way, and we're going to use the full range of nodes that the FX map offers. So go inside the FX map, and this is the quadrant node. We're also going to use the switch node, and we're also going to use the iterate node. Okay, so these three nodes. And I think in this way things are going to make a bit more sense. This way of working is different than what we've been doing before. I just want to let you know about different ways of working with the FX map. That was the first one. We're going to switch gear and use a different way of using the FX map node. I think this one is a bit more interesting and more powerful, and also it's more relatable to people who come from a programming background. Okay. Right. Let's do this second part by talking about how to use the FX map node with data. So we're going in this intermediate part to use the FX map node to read and write data. Good. Let me just do this. We're going to use a white noise. So what we're going to do right now is we're going to scatter a bunch of random points into this space. So for this I will be using a white noise, like this, and I want to make this as a list of points. So this texture contains right now 256 by 256. I will just do a 256 by 1 texture. So this is a row of random values. I'm going to duplicate this one. I'm going to take this and just change the random seed, and then I will use a FX, not an FX map, but like a pixel processor node to just combine those two things into a list of 2D vectors, right? So plug this thing here, plug this thing, this is the X, this is the Y component. It's going to create a list of 2D points for us. This pixel processor node has to be the same size as our input nodes. So absolute, the width is 256, it's good, but this needs to be 1 pixel. I'm going to go inside, get the position sample, the first one, sample the second image, make a vector out of those. So basically you're combining those two streams of data in one vector, and then we need, remember, we need to either output a float or a float 4. Currently this is a float 2, so we need to add another float 2 into the stream of information and just make the alpha to 1. Set this as an output, right? So you see these random fluctuations, those random pixels of red and green. These are 2D points. And now good, let's actually plot these points and see how they look. Definitely they're going to look like 2D cloud of points that are just sitting randomly there. So FX map, right? Make it grayscale, go and make the roughness to 0, plug this list of position inside, go get the quadrant node. I'll be using the max blending mode. I'll be using the disk. Let me preview the output of the FX map. So let me decrease the size of the disk. So pattern 0.01 and 0.01. Okay, should be 1, not 5. And then we're going to use the iterate node, and we're going to iterate 256 times and set this one as an output. Okay, so what we are actually going to do, the FX map node is going to look into this texture that it's actually a list of 2D points, and it's going to read 1 pixel at a time. So it's going to start here, read this pixel, and then draw or place a circle into this space at this position, and then it's going in the next iteration, it's going to move to this pixel and it's going to read the position from here and place 2D disk, like a disk into this space, and so on. It's going to walk and read the entire list pixel by pixel and then place a disk into this space according to the position indicated here. So let us do this. So we're already iterating 256 times. Although you don't know, you currently have 256 points sitting on top of each other, which it's great. Then we need to go inside of the quadrant now, and if you remember, where do we want to go to make sure that we're moving things around? Where we need to go here into pattern offset. Okay, so then we're going to have a way of reading from that texture. Well, previously we used the get float 2 to bring in information, right? We use the position, but in this case we want to read pixel by pixel from here. So we will use a different method, and we're going to make use of the iterate node, and it's the iterate node produces a variable that we can use. And I want to at this point to say that this iterate node, it's very similar to a loop in programming language, and it's producing a variable that it's called dollar number. But this variable, it's very similar to like I or I plus plus. Okay, so this is running 256 times, and it's producing a variable called dollar number, which starts from 0 to 1 to dot 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 until 255, right? So it starts with 0, not with 1, and it ends with n minus 1. So this was 256 and it ends in 255. Great. So now we want to take and use this variable that allows us to read the information from the texture. So we need to make like we need to sample the data, right? This is the incoming information. We need to make sure that we're plugging a vector 2 because this is what it wants. And then we're going to only use this part here because of course we're going to use like the x coordinate. So we're reading from left to right, we're moving from in the x direction from left to right, not up and down. So we're going to use only this stream here. And we need to take in the information, which is get float dollar number. So a get float and dollar number is this, and this starts from 0 and ends with 255, and we're going to just divide this by float. And I usually, this is like where you can call me out and say like, hey, this is wrong and things like that. You can divide this by 255, and then for sure you're going to have a range starting from 0 to 1. But I usually do like 256. In this case, it's kind of a simple thing and doesn't need like really too much precision. We just need to take this uh, range of numbers, which is from 0 to 256, divided by 255, divided by 256 to just make it from 0 to 1. And in this texture, the coordinates are like 0, it's here, 1, it's here. So that's why we need to kind of step in small increments of 1 divided, or yeah, in increments of 1 divided by 256. This is basically the step between pixels. So this is what we're doing here. This is now in the range of 0 to 1. Just plug this thing here. And now we want to output this information, which is like just reading the positions from the texture itself and then plotting those points in 2D space. Let me try and output this. So I want to, but I can't because set as an output node it's deactivated. And the reason for this is because again, the expected type output is float2. Now this makes sense because we have 2D positions and those information are stored in the X and Y components. So this is a float4 which has X, Y, Z and W, and we only want the X and Y. So Swizzle float2 decomposes this float4 into a vector float2. And let me just preview this thing. Okay, focus. Currently nothing yet happened because I haven't set this as an output, but then if I set this as an output, now we get a grid of positions. Great, everything worked, but I want to show you something. This happens when we use the FX map node. The FX map node has the 0, 0 coordinate in the center, and usually the 0, 0 coordinate in the Substance Designer, it's here at the top left corner. So if I go here and deactivate the tiling mode, you can see that we're actually starting from here, and we only um, fill the space in this region because 0, 0 is here and nothing else is visible. So we always, when we're like this, we always go here into the quadrant node and we use the branch offset to offset everything with the 0, 0 here. So in order to do that, we just need to put like a minus 0.5 and minus 0.5 here. Okay, that's great. Now we have it correctly. And it's good because now we can also use textures uh, to work with the points how we wanted. So maybe we can, how we did before, maybe we can go and we can access or change the scale of the points based on a map. So again, you know that I love Perlin noise, and maybe decrease the scale and then something like this. So how to use this Perlin noise to affect the points um, based on this map here? Well, that's an interesting question because we kind of don't have direct access to how we had before, which we can't just go here inside and say like, hey, get position, get flow to position, and then sample gray, and then vector float to. I don't think this will actually work correctly. So it seems like it's doing something, but not entirely sure if this is correct. Maybe I can just do this. Scale everything down a bit so we can see more. So if I do this, everything disappear, but now I can increase things. So it seems like even though we're using, right, I mean, should be the texture 1, not 0, so nearest texture 1, okay, and then decrease. It seems like it still doesn't work correctly. You can see that there seems to be the circle seems to have the same size everywhere. Okay, maybe I can try and test it because I multiplied all the values by this 0.04. Maybe it's making it difficult to see. Let me try and, I don't know, just use the levels to increase the contrast. So I will make this more like contrasty to have like very sharp contrast between black and white, and this should cause some of those dots to change sizes. But again, seems that it's not working. It seems like it's affecting everything at the same time, so not individually. Okay, so it means that we need to change our setup and use a different method. And currently you remember that we calculated already our position. So our position is read from the texture itself. So what I can actually do is take the same logic from here, and this is reading the information from this texture here, and it's plotting the points into this space. But I can use the same information, so duplicate this one or just copy it and move here into the pattern size itself, copy it, and then I want, because this is producing the positions for my disk, but at those positions I want to read from the map of my Berlin noise and resize the disks based on the value of the Berlin noise at each circle position. So I have the position here, and then I just need to sample with this position. I need to sample the Berlin noise. And now I want to visualize this, of course, and then go here and put like a vector float 2, and then probably I should multiply by something, a scalar multiplication, maybe a 0.08, something like this, and just output this one. Okay, so now it seems to be working, and it's working correctly actually. And if I change this order, you can see that it's correct. And also I want to test it, so I can just maybe use a blend node. I think this is a bit more clear and in the way we're used to work. So what I'm expecting to see is that in those bright regions, I should see like brighter, or not brighter, but larger disks, and in those areas where it's dark, I need to, or I expect to see smaller disks. Okay, so I'll just be decreasing, and you can see that when I have disks in the larger region, in the brighter region, the disks are larger, and in darker regions, the disks are smaller. Okay, good. Now changing the disorder actually shows that our thing looks correctly. Good. So still, why do we work like this? Well, it's sometimes useful to have access to the information like this in a texture, because, for example, let's say you could just put a blur node after this, and it's going to blur between the pixels, and remember, those are positions. So then when you read those positions here that are blurred, this map of disks here is going to be affected by that. And I think that's a very interesting way to work with. So let me do another example, or maybe continue on this example to show you like a different thing to do to work with the data. I'm going to just duplicate this and say like, hey, I have the list of position here, and then I'm just plotting things here. And this is really important to have this distinction right now. It's good to introduce it. So let me put a frame. Where are the frames? So data, and draw. This is a new concept, a new idea that is really, really powerful. We are splitting the data from the actual drawing. So we kind of dividing our work in two pieces. Maybe you can think about it like data space and draw space. This is a critical new concept that is going to be very, very powerful. So make sure that you spend a bit of time and try to understand or get yourself more comfortable with this idea, because it's really, really powerful, separating the data from the draw. You work with the data and you work in a particular way, or you have like specific tools for the data, and then once you work with the data, then you get to actually read the data and draw it. This is really, really powerful, so I can't emphasize it enough. So data and draw. Maybe I make data red because it's critical and important, and draw green because it's where we're going to get the green light. Okay, so I have this example here, and then I have this duplicated example here, but I want now to work with the data separated from the drawing itself. So go here at the data, and now these are our positions, right? And I want maybe to move the points around or do something to them. I can rotate them or stuff like that. Well, yeah, I can do this. So this is my list of position, and I want to maybe scale them and not have them being spread on their entire space, but maybe have them occupy like a smaller region in the center or towards the center. Well, for that I need to do the following. I need to do like I really want to scale things, but from the center. So in order to do this, I need to subtract. I will do subtract 0.5. So this is our pivot of scale. Then I will use a scalar division node. So scalar division float 2. I will put a 1 for now here. So dividing by 1, it's going to do nothing. So actually make the connection correctly, and then at the end I will add back this pivot. So I will be just adding this like so. Okay, so maybe make this a bit more visible. So this is what we are doing. I will put this in a frame and then say like scale with pivot, and then plug this thing here. So nothing changed, right? Because we divided by 1. So of course division by 1 leaves the things as they were. But now I can maybe increase this, and it seems like all our points are shrinking towards the center, right? That's pretty cool stuff. Now let's try and play with rotation. And also this is interesting because the order of operation really matter all the time. So we scaled things, but I want to maybe change the rotation of all those points together. How to do this and where to do this? Well, to be completely honest, even though I've done it so many times, I'm still confused about the order of operations. So I'm just going to guess and check. So I'll be either putting the rotation here between the positions and the scale, so here, or maybe I'm going to put it here. First, let's try here and see if it works. So rotate. So we have this rotate 2D. We're going to put the vector here. So this is the positions that we want to rotate. We want to rotate by a certain angle. For now, we're going to put 0, and we also want to rotate with the pivot. So maybe from the center, maybe 0.5 and 0.5, something like this, right? And also sometimes you just need to play around. I think depending on how much you play with and how much you understand your examples or the things that you do, you're going to figure it out. But sometimes I end up changing this from 0.5 and 0.5 to 0, something like this. So it depends. Plugging this thing in, and then use this here. So it seems to be that the effect that I wanted, it's working just fine. Yeah, so it's rotating around the center. Maybe I can just play with this pivot. So you can see, like, if I change the pivot, now it seems to be rotating around another point. So it seems to be rotating around this corner, but I'm going to just leave it like around 0.5 and 0.5. So I have like scale, this is rotate. And then I also want maybe control to move. So I have move, scale, rotate. Those are the most common operations that we do. So I can either add rotation, movement either here or here. Well, again, I don't remember the correct order of operations, but I will be testing. So maybe I'll add here or here. Let me try here, because I have like an intuition like, hey, we already did the rotation, we already did the scaling, maybe after everything we should do the movement. So add, For movement, we just add or subtract. Adding nothing does nothing, but we need to put like a float too, and then see what's happening. So it seems that the movement is correct, so maybe at the end we should do the movement up, down, left, right. Okay, so maybe let me move this, and I want again, so even if I move, so currently my center of points, or my center of the mass of all the points, is in the middle of the texture. But if I move things around, I still want my points to move about their own center. So still want to move from here, not from any other center. So I hope this is going to keep my rotation meaningful. And yes, indeed, it's still doing like so, which I really like. Perfect. So we have rotation, scale, and move. Maybe this is the order of operation. I always encourage you to test things. So move. Great. And this is how you work with data in Substance Designer. And the critical point here is that you want to split things into data, and then you want to draw. So great. Let me do another example in which we're going to blur the node or blur the data. So for this case, I will be doing a white noise again. And we're going to decrease this texture, of course, because we don't want this many points. Maybe 32 by 32, something like this. So we're going to create a grid of 32 by 32 points. Duplicate this node once more, change the random seed. We can, what I really want is again to create a list of points like this. This time the list is going to be two-dimensional, not in one row. Instead of using a pixel processor, which is totally fine, I can just use a RGB merge. Okay, so this, and we need to uniform textures, maybe absolute uniform colors, sorry, not textures. Put a 0 for the blue channel, dock it, and then maybe this one for the... Okay, so this is a list of random points, but it's stored in 2D, and the reason for this is because I just wanted to use the blur node. The blur node doesn't work really good, or I think doesn't work at all with a 1D texture like this, but it works with a texture, with a 2D texture. So that's the only reason that I'm doing a list like so. Okay, so I want now to show you how to use the FX map node to plot this list of 32 by 32 points. So FX map, starting again from scratch, grayscale, do this. Okay, bring the go inside, bring the roughness down, going into the tiling mode for now, and just set it to no tiling. This is good, so you will not forget that your 0, 0, it's actually in the middle here, so you need to go in the beginning just for debugging purposes to go and deactivate this tiling, and then you'll know for sure where your things are in space. So going inside, make a disk, make it small, maximum pattern size 0.05, 0.05, I mean even more, something like this. Okay, move it such that now the 0, 0 should be here. So move it, pattern offset, branch offset. Here is where we move this generally. So now it moved here, and now it should move at the top. Great. Now do a loop like this. Okay, so in this we're going to, let me think about it. This is columns, this is rows. I will just do two of those things together, chain them. So this is a nested loop, right? And we're going to make, this is going to read each pixel in a row, and then this is going to go down row by row. So this is going to kind of be like the columns, but maybe no. The simplest way to think about it is like, hey, I mean, this is the inside loop. Yeah, so disregard for a bit everything and just let's go through this again. So this first loop, it's going to say like, okay, read pixel by pixel from this texture. So I'm going to zoom on this one, and it's going to be the first loop is going to, or the first iterate node is going to be like this. Read each pixel in a row, one by one, and then when it finished itself, then this loop is going to move to the second row and is going to read one by one, and then this finishes, and then this loop goes to the next row and things like that. So the inner loop is going to read all the pixels in a row one by one, and then the outer loop is going to move from row to row. Okay, so maybe I don't know how to name them correctly. Usually there are like indices. Maybe we can put like I, like in I++, and then this may be J, something like this. So inner and outer loop. And I will be leaving this a bit above just to say that, hey, this is the outer loop. Good. We need to specify how many times this thing should iterate. Let's make it in the correct way. So if I change these textures, this updates automatically. So this texture is 32 by 32. Well, in this case, I will be going here and just say like, hey, iterate 32 times, iterate 32 times. But there's an automatic way, because if things change, then I also want those variable, those parameters to change. So instead of manually changing them, I will use variables. So we get node that's called get size color. We have 32 by 32. This is outputting a vector float too. Need to go into this one, add a parameter, then float 2, right? Plug this thing here, and then this part, this first component of our vector, it's going here at the top. So in this outer loop, get float to input swizzle float x, and then I want to put this as an output, but I can't. This is because, again, I need to pay attention to the required type of variable that Substance expects. It's an integer, this is a float. I just need to convert or to cast it from float to integer, so just to integer. So with this one selected, press space and say to integer. Okay, great. This works. Perfect. Now need to output this one, go into this one, go again, get float to its input, swizzle float 1, this is y, and then I need to go with this one and to integer. Okay, great. Perfect. We have those things together. Let me think about something. Yeah, well, for now, just leave it like this. I will cover that aspect that I wanted to talk about a bit later. So currently we set it up the inner and outer loop correctly. We need to go inside and just read these positions. Okay, so where should we go? We go into the quadrant node, we get into pattern offset, right? and we're going to get the variable. So we need to get float, and we need to get the number, and it seems like we only have access to this variable, which is dollar number. And which one is it? I mean, this is producing the dollar number, this is also producing the dollar number variable. Well, which one we're actually getting here inside? Well, this one here, it's reading information from this one, but we also need access to this thing here that's producing the dollar number variable. So how can we access this? Because we also need to access this thing. Well, we need to go here inside and take this one, so get float dollar number, and just put a different name. So for example, I would say like set, and I will set like outer loop. And this is like, you can put whatever name you want, but in order to have access to this, to the dollar number variable that this produces, you need to get it one level below it, and then set it to a different name. Or maybe I can put like just J. I think this is might be simpler. And then next I need to connect these things together, because I can't just go here and set this one as an output. So for this we have the sequence node, which is like separating lines of code. This is the first line of code, it's executing this, and then this is the second line of code, and this is executing this. And we need to plug the thing that it's required as an output in this channel needs to be the last thing that we put into the chain of sequence node. So currently this is how many times we want the iterate node to iterate, which is 32, and then we need to set this as an output. So now we have, this is producing the J variable, this is producing the dollar number variable, which is fine, but we need. So maybe for the sake of consistency, we can do this here. So now this dollar number, it's from this thing here, and I can go here and set it to I. So we have I and J, and then put a sequence node. And then we just have like, hey, we want get float, we want I, it's from 0 to 31, right? And then we want to divide it, well, I can put it here, maybe 32 if I want, but I don't want to be hard coding numbers. So remember, we have get float to input, right? And we want this. So this input X, it's reading this part from here, and I want that, so I divide it by this. And then also we want J divided by this, so Y, it's the second component of this vector, this one here. And this is producing us the coordinates that we want to read from. So we need to make a vector out of them. Okay. And kind of this is our dollar position variable, but in fxmap. And now we sample from it, and then we need to extract the information that we want, which is the position here. Okay, now plug this thing here and set this one as an output. So voila, we have read the points from our texture. And now that we have it here, we can just go and do the blur. So does the blur do anything? So it seems that it's doing nothing, which is weird. Why? Let me try and figure it out again. So double click here. Maybe sometimes the substance designer gets weird, I don't know, or maybe I've made a mistake which I haven't seen yet. But when things go sideways, I just double click the entire graph and maybe change the seed, something like this, and then do the blur node, which for some reason it seems that it doesn't want to work anymore. Just put like another blur node. Yeah, this one wants to work. This one got upset and it doesn't want. Or maybe it's maybe the intensity is a bit too low. Probably that's the reason. Maybe 5. Yeah, okay. This seems to be working. Sorry about that. Okay, so let me preview the points. So voila, we have data, and now we're currently only working with data, and when we blur it, we get this kind of effect, which I think it's interesting, right? So again, we're working with data separately from the draw. And again, I want to emphasize this. So data and draw. And do again the green and the red. Something like this. So if you want to make more sense of this, and maybe in some future tutorials I'm going to show more of why and how to use these kind of things. Let's just think about like, hey, I want to do a simulations where I have points. Maybe those are like, I want to do like a particle simulation or anything like that, and I have those points, and these points are like positions, but then I can take those positions and add like velocity vectors to them, and then update the position based on forces and velocities. And then I can also use like maps like Perlin noise to say like, hey, maybe those points are like bigger, and if they are bigger, basically they have like more force, or they move slower or faster and things like that. So you can get like pretty crazy and interesting just by using with information like this. So here I have positions, and I can add to position, I can blur them, I can rotate them and things like that. And then after I work with my data, and I just take the data and plot it or draw it. So that's why I think this workflow is pretty powerful. And let me, so we currently have done this in which we had the data, and then we use the FX map node to just read the data. Before moving on into the last section where it's going to be like the most advanced example, I want to show you like, hey, the FX map node, it's not only for taking in data and reading it, but you can also generate data with the FX map node. So the FX map node up to this point was used to draw, but it can also be used to generate data, and also used to take that information and inside and draw it. So I'll be making another simple example of FX map like so. Make it grayscale, make it the roughness like so. For now, I'm just going to leave the center to be at in the to be the 0, 0 coordinate to be in the center. So just bring a disk, make the disk something like this and something like this. Perfect. So I have the disk right now, and I want to just create a spiral thing from this point. So maybe use an iterate node. For now, maybe just do like 32 iterations. Set this one as an output. Go into pattern offset. I will be using this Cartesian node, which takes in a length and an angle. and outputs a position. So maybe the length will always be constant, maybe, maybe not. Well, I'll figure it out. So for now, I will be just putting like a constant length. Maybe 0.05. I don't know. This is going to be the radius and then an angle. So for the angle, I have 32 iterations, right? Yep. And then I need to take dollar number, divide float by 32. Hard coding is not good all the time, so I shouldn't be doing this because if this number changes, then also this need to change. But currently, because for the sake of simplicity of this example, I will be letting it like this. And it's not like super wrong to do it, but just for the sake of making things really procedurally, make sure that you store things in variables, and then once you update a variable in one place, then that variable gets updated everywhere else when it's called, right? Okay, so this is a radius, this is an angle that goes into here, and this needs to be now this outputs from 0 to 1, right? The dollar number, it's a list of number from 0 to 31. If you divide everything in this list by 32, you almost get a range from 0 to approximately 1, just a bit below that. And then this is taking an angle which this node like to have the angles between 0 and 2 pi, but this one goes from 0 to 1. So in order to make it happy, we need to multiply this by 2 pi and plug this thing here. And then if we output this, we're getting a beautiful circle. As I mentioned, this allows us to do things around the circle, and then this is the radius. Okay, so what if I want to make a spiral? Well, as you can see, what I actually need to do is I need to make the radius, instead of having it a constant, I need to make the radius to be like something that changes in time. Well, I can do that. I already have this thing here that I computed, so also it changes in time. It's something that changes from 0 to 1 as the number of iteration increases, so I can just use something like this. Maybe I'll start with I'll use this one to have like a start variable radius of 0.1, something like this, and then from this I want to increase. So I can add to this. Adding nothing does nothing, but then if I plug this thing here, you can see that things kind of spiraled out of control. That's totally fine. If you want to get rid of the noise thing going on, this is because of the tiling mode. If you deactivate it, you can see how or what really happened. And maybe this increased like really too fast. I can just multiply this by 0. This returns back to how it was before, because multiplying this thing by 0, it's always 0. But then I can just put a number here and increase this number. So this is going to let us do this. Okay, so we're getting a spiral like that. Okay, maybe what if I want this to wind more around the circle? How can I do that? Well, that's simply like a really simple thing to do. I can just multiply this by another number. So I'll be putting after this a multiply. Multiplying by 0 does nothing for the angle, but maybe I can multiply it by 2. So I mean, for now, just leave it to 1. This returns to what it was before. Below 1, it's like this, and greater than 1, if I can actually manage, it's do the spiral like this. Okay, maybe I want to add more points. I think 32 points are maybe too little, so I can put like 256. And kind of I really like this pattern. but it's not like super correct. Remember that we also need to divide by 256 here. So now it's like this. Now seems to be what we should be getting. Okay. So perfect. We made it like this. We made a drawing like this. But what if I wanted to, instead of having the drawing here, what if I want the FX map node to produce the data? And then I can work with that data even more and maybe, I don't know, process that data somehow or extract information from it and then redraw it. Well, if you remember here, we had like a list of texture that had 256 points, where currently here I have a drawing that has 256 circles or disks that produce this spiral, right? So it means that I can try and do this FX map, but instead of drawing it directly, I can just use it to create for me a list of positions that are the same information as the spiral. And then lately I will use another FX map node to read that data of positions, right? So how to do it? Well, I'm going to do another FX map node, which is FX map, this one. I'm going to leave this one as color because we are going to create a texture of colored pixels, but I want to change its format and resolution. So I will be setting this to absolute. The width, it's correct, it's 256. This is how many points I want to output, but then I want the height to be only a row. So 0 is going to produce a 1 pixel row for us. Going inside, I will be making sure a few things happen. So roughness, I will be letting this to 0. I also mentioned that I want to change the format. I usually work, whenever I work with data, I usually work with 32 bits precision, so output format, it's in 32 bits. And then I'm going inside, and for the pattern size, I will choose a square. So everything went white. Before it wasn't white. So if I go here into no pattern, you can see we have like this gray white checker like pattern. But then if I go into square, then everything turns into white. So first of all, we need to figure out the size of the square. We want it to be 1 by 1 pixel. So with the quadrant node selected, go into pattern size, empty function. You have this variable getFloat2, which is $size. This is the information that it's actually the size of the node itself, which is 256 by 1. And we just need to divide 1 by this variable. This will always produce a square that will have the size of 1 pixel. No matter how much we change the resolution, no matter in what way, this expression, this division, will always produce a pattern that has a 1 size pixel, which is what we want. So where is our pixel? Well, our pixel is somewhere in the middle of the texture, which might be a bit tricky to find. So maybe I kind of can see or find, oh, there it is. This pixel here is in the middle, but I want it to start here at the beginning. So for this, just going here and into branch offset, if you remember, we need to put like a minus 0.5. So now we should find our pixel here, which is perfect. And now we want to produce our data, right? So we need an iterate node. This iterate node should be like 256. Make it the output or the root node. Then make this one as a max. And then we will be working with 2 channels. So for one, we want to take this square and move it 1 by 1, right? And then we also want every pixel in this texture, we want to actually contain the position of the dots in our spiral. So for this, we're going to use the luminosity channel. And here is where we're going to produce the information, the actual positions, right? So what we've done before, let me, how should I do it? Should I copy that thing? Maybe don't copy it. Try to rebuild it from scratch, but then for exactness, we might be, if we want to make it exact, we might be revisiting that node just to have a look at of what values we used. So, but I remember we had like a Cartesian node, right? And then we had a constant radius, which was 0.1, like so. And then we had something that we multiplied by 2 pi, an angle, so multiply by 2 pi. And then we also multiply this by 2 after everything, so multiply by 2. That was like how much we want the winding around the center was, our spiral was doing. So maybe float 2, something like this. So this is our setup for the angle, this is our setup for the radius. If I remember, we added something here and then we need to put stuff here. So our changing angle is coming from the get float. From the get float number, we need to divide this by 256, right? Sorry, 256. And then plug this thing here. So this is going to create our circle, but then we also need to change this in order to make our variable radius. So we took this one here, but we also multiplied it by something. Okay, so float maybe 0.1, I don't know, something like this. I mean 0.1, but then I actually type 0.2, maybe 0.1. Okay, so this is the information. This is the colors that are going to be on the pixels. If I put this one as an output node, well, currently it doesn't let me because it wants either a float or a float 4. This is a float 2, so we need to put like another to make it a float 4, and we need to complete the stream with information. So 0 for the blue channel and then 1 for the alpha. This allows me to do this, so we can see that this pixel here got colored with something, but currently I have like 256 squares sitting on top of each other, so I also need to move this thing around. So, well, I want to show you a cool trick that you can do, and I also want you to get used to this. We usually find that it's really helpful to compute everything into the luminosity channel. This is the first thing that Substance Designer compute in the FX map node. It computes the luminosity, then the pattern offset, or I mean branch offset, pattern offset, size, variations, and things like that. It's really helpful to set up everything here and then just call variables later, because you might be finding yourself recomputing things multiple times, but you already had them computed here into the luminosity. What I'm talking about is I already computed this dollar number divided by 256, and I don't want to compute it here again. So if I will be moving into pattern offset empty function, then I will be needing to get the dollar number and divide by 256 here as well, which I don't want to do, right? So then I can take this thing here and name it offset. So I'm going to set this as a variable. So not the sequence node, I mean I will be using the sequence for later. Set. Okay, so I'll be naming this computation here just offset. I mean X offset. And remember how you spell things. This is really, really important. Make sure that you remember the name or how you spelled it. So we're storing this computation here, and then we plug this thing here, and we lastly in the sequence now we plug the thing that we want to output. In this case it's our float 4 from here. Setting things as an output, well, nothing changed, but this is correct. But now we want to use this variable here. Okay, so going into the pattern offset, we need to output a float2. We need to make a vector float2. For the y component, because we're not moving nothing up and down, we're just going to plug a 0 here. But here in the x, we want to take this square and move it like 1 by 1. And we just made the variable for that, which is x of set, right? So if I've done everything correctly, now this texture should be filled, this entire row should be filled with 1 by 1 squares containing the positions of our spiral. So let me set this as an output, and apparently it looks like so, which is great. Now let me try and plot it. So now we have this almost the same thing as here, but it's stored in a data, and we can take this data and furthermore play with it like how we've done before, which is great, right? But now I want to take this data and read it and plot it. So we split everything into data and draw, which I'm going to do next. So fx map node, make it grayscale this time, plug this information into image input 0, go inside, set a disk. I mean, maybe not a disk, because I want to use the opportunity to show you something else. Just a square for now. Make the square smaller, like 0.05, 0.05, maybe 1515, something like this. Iterate. We want to iterate 256 times. I'm going to hard code for now, but make sure that if you want to be fully procedural, make sure that you use variables instead of by hand typing numbers here. Okay, go here inside. We just want to read information in pattern offset that it's going to move our squares around. We want to get the, not the float 2, sorry about that, we want to get the number, divide by 256, make a vector from this sample, our input data, extract the x and y component, then set this as an output, and voila, we have our spiral, which is coming from the data itself that we just wrote. But I also want to show you something else. Maybe if I'm going here and put like 0.5, what if I want, for example, even less, maybe to 5? What if I want to orientate those these rectangles? What if I want to orientate them so have them not sitting horizontal but actually being aligned? So this one should be going from here to here, and this one should be going from here to here, and things like that. How can I do that? Can I even do it? Well, yeah, I can do this. So I can just go here and take this information that I already have. So this is my position, and I need to take the R8 and 2. So this is giving me an angle, okay? And then this is outputting from minus pi to pi, but I want it to be from minus pi to pi. I want to be in the 0-1 range, because this pattern rotation here reads only from 0 to 1. So 0 to 1 turns, okay? So you can see that this is what we need to do. And then this is from minus pi to pi. So first of all, we divide by pi. And now this is from minus pi to pi. Now it's between minus 1 and 1, and I will need to turn this into 1 and 1. So we have this node minus 1 1 to 0 1. Perfect. And I want to set this as a set. I will be saying like rotation. Okay. And then have this sequence node. So I'm computing a rotation, but lastly, I want to output a position. Nothing changed. But then if I go in here into rotation and get our variable, which just computed above, and call it, and then set this one as an output, we should be seeing an alignment. So okay, so we have it like this, which is interesting. I kind of like it like this. So before was like maybe 0, so it was like this before, and now it's like this, which I like. But then what if I want those things to be making a line, so to speak? Then I just go in here and do something like this, add, and it seems like I need to rotate 90 degrees. Well, remember we are here in turns, which is like 0 to 1. It's a 360 degrees rotation. Well, a 90 degrees rotation is like 0.25. So now we have it like this, right? And everything seems to be like a spiral line. So depending on how you like it, you can leave it like this or like this. I'm going to leave it like undecidedly as a diagonal, right? Okay, perfect. So maybe I want to add some randomness to this thing. Well, I can do that if I want. So I have the data here, I have the plot here. I just want to expand the data space more, make a pixel processor node, right? Make this absolute the same size. It's important to have it the same size. I mean 0 here. Also make it the same depth format, I mean 32 bits. Take this thing inside, read the information, so get float2 position sample, set as an output. This is our information, nothing changed. If I plug this thing here, nothing happened. But then I want to take those positions and move them around randomly. Can I do that? Well, yes, I can. So I want to do like a thing. Maybe take the white noise again, make it a list of random angles like this, plug this thing here inside, read this thing again, I mean as well. And then I want to add to those positions here. So swizzle, float2. So in X and Y channel, I have those positions. I want to add something to it. And these are going to be some random angles coming from this texture. And then I want to use those angles to create some randomly pointing vectors and add those to my original position. How to do this? Well, it's kind of pretty easy. I need to use another Cartesian node. This goes where my angle goes, but this is from 0 to 1, and this needs to be from 0 to 2 pi. So then multiply this by 2 pi. Perfect. And then lastly, we need to do a certain constant radius. So maybe 0 for now. Just add this and then float4, float2, set this as an output. Okay, nothing changed yet because this radius is still 0, but now if I do this, you can see like everything is randomly pushed around. So I'll be leaving this just as like maybe 0.01, right? So we had this thing where we have data and we basically worked with the data itself, and then we read the data and drew it. And I think this adds like a really cool way of working around and adds a lot of new possibilities and flexibility. Perfect. So I think we finished